The Earth, from space, is often called the blue planet. This striking color comes from the vast expanses of water that cover more than 70% of its surface, forming what we call the hydrosphere. This water, whether in oceans, rivers, lakes, or locked in glaciers, is not just something we take for granted in our daily lives. It is the lifeblood of our planet, shaping weather, supporting ecosystems, and sustaining all life forms. Without the hydrosphere, Earth would be an entirely different place, barren and devoid of the complex web of life that thrives on it today. The hydrosphere is an intricate, interconnected system of all the water on Earth. This includes water in its liquid form, like the oceans and rivers, but also its frozen form, like glaciers and ice caps, as well as water vapor in the atmosphere. Every drop of water, from the smallest trickle in a stream to the vast expanses of the Pacific Ocean, plays a role in this system. Even the water beneath our feet, hidden in underground reservoirs called aquifers, is a crucial part of the hydrosphere. All of these forms of water are in constant motion, moving through a cycle that is as ancient as the Earth itself. To understand the hydrosphere, we must first appreciate the water cycle. This cycle, often called the hydrologic cycle, is a continuous movement of water through different parts of the Earth. It begins with the heat from the sun, which causes water from oceans, lakes, and rivers to evaporate into the atmosphere. As the water vapor rises, it cools and condenses into clouds. These clouds, carried by wind, eventually release their moisture as precipitation, rain, snow, sleet, or hail, depending on the temperature. This precipitation then falls back to the Earth, where it replenishes rivers, lakes, and the ground, and the cycle begins anew. This cycle might sound simple, but it's incredibly complex, involving countless variables that change depending on location, season, and climate. For example, in tropical regions near the equator, the water cycle is rapid and intense, with warm temperatures causing high levels of evaporation and frequent rainfall. In contrast, in polar regions, much of the water is locked in ice, and the cycle operates at a much slower pace. However, despite these differences, the water cycle connects all parts of the Earth, ensuring that water is continuously moving between the atmosphere, land, and oceans. Oceans play the most prominent role in the hydrosphere. They contain about 97% of all the water on Earth, and they are the main driver of the water cycle. The vast surfaces of the oceans provide the majority of the water vapor that rises into the atmosphere, fueling weather patterns and precipitation. But the oceans are not just passive bodies of water. They are constantly in motion, with powerful currents sweeping across their surfaces and deep beneath them, transporting heat and nutrients across the globe. These ocean currents are essential to regulating the Earth's climate. For example, the Gulf Stream, a warm ocean current in the Atlantic Ocean, brings warm water from the tropics to northern Europe, keeping the climate there much milder than it would otherwise be. Despite the dominance of the oceans, freshwater water that we can drink and that supports most life on land is actually quite rare. Only about 3% of the Earth's water is fresh, and most of that is locked in glaciers and ice caps, especially in Antarctica and Greenland. The remaining freshwater is found in rivers, lakes, and underground aquifers. This small percentage of freshwater is what supports nearly all life on land, from the largest trees in rainforests to the tiniest insects in deserts. Freshwater ecosystems, like rivers and lakes, are some of the most biodiverse places on Earth, providing habitats for countless species of plants and animals. Rivers and lakes, though they hold a much smaller volume of water compared to the oceans, are crucial to life on Earth. They are the arteries of the planet, transporting water from one place to another, supporting ecosystems, and providing water for human use. Rivers, in particular, have shaped human history. Civilizations have risen and fallen along the banks of rivers like the Nile, the Tigris and Euphrates, and the Yangtze. These rivers provided water for drinking, agriculture, and trade, making them the lifelines of early human societies. Even today, rivers continue to play a vital role in our lives, providing water for agriculture, energy through hydroelectric dams, and transportation routes. Beneath the surface of the Earth, hidden from view, lies another critical component of the hydrosphere, groundwater. This water is stored in aquifers, underground layers of rock and soil that hold water like a sponge. Groundwater is an essential source of fresh water, especially in regions where surface water is scarce. In many parts of the world, people rely on groundwater for drinking water and irrigation. However, unlike rivers and lakes, which are replenished relatively quickly, groundwater is replenished much more slowly. It can take hundreds or even thousands of years for rainwater to seep down through the soil and refill an aquifer. As a result, groundwater is a finite resource, and overuse can lead to wells running dry and land subsidence, where the ground sinks because the water beneath it has been depleted. In addition to the water in rivers, lakes, and underground, a significant portion of the Earth's freshwater is locked in ice. Glaciers, ice sheets, and polar ice caps store vast amounts of frozen water, covering about 10% of the Earth's surface. These frozen reservoirs are vital to the global water cycle and climate system. As glaciers slowly flow and melt, they release fresh water into rivers and oceans. In fact, during periods of global warming, when glaciers and ice caps melt more rapidly, sea levels rise, affecting coastal communities and ecosystems around the world. The polar ice caps, particularly in Antarctica and Greenland, are the largest stores of freshwater on the planet. These massive ice sheets contain enough water to raise global sea levels by many meters if they were to melt completely. The melting of these ice caps is one of the most pressing concerns related to climate change, as rising sea levels threaten to inundate low-lying areas, displacing millions of people and altering coastal ecosystems. Water, in all its forms, shapes the world in ways both seen and unseen. It carves out landscapes, like the Grand Canyon, formed by the relentless erosion of rock by the Colorado River over millions of years. It nourishes ecosystems, from the lush rainforests of the Amazon to the arid deserts where plants and animals have adapted to survive on the smallest amounts of moisture. Water also influences weather and climate, as the movement of water vapor through the atmosphere drives storms, hurricanes, and other weather patterns. One of the most fascinating aspects of the hydrosphere is its role in the climate system. Water has a unique ability to absorb and store heat, which makes it a critical factor in regulating the Earth's temperature. The oceans, in particular, act as a giant heat sink, absorbing heat from the sun and distributing it around the planet through currents. This process helps to stabilize the Earth's climate, preventing extreme temperature fluctuations between day and night or between seasons. However, this ability to store heat also means that the oceans are playing a significant role in global warming. As the Earth's atmosphere warms due to the buildup of greenhouse gases, much of that extra heat is being absorbed by the oceans. This has led to rising ocean temperatures, which in turn affect marine ecosystems, weather patterns, and even the intensity of storms. Warmer ocean temperatures contribute to the bleaching of coral reefs, the loss of sea ice, and the disruption of marine food chains, all of which have far-reaching consequences for the planet. The hydrosphere doesn't exist in isolation. It is deeply interconnected with the other spheres of the Earth, the atmosphere, the air, the lithosphere, the rocks and soil, and the biosphere, the living things. For example, the water cycle is driven by interactions between the atmosphere and the hydrosphere. Water evaporates from the oceans into the atmosphere, where it forms clouds and eventually falls back to the Earth as precipitation. This water then flows over the land, interacting with the soil and rocks of the lithosphere, before returning to the oceans, completing the cycle. The biosphere, which includes all living organisms, is also closely linked to the hydrosphere. Every living thing on Earth depends on water to survive, whether it's the largest whale in the ocean or the smallest microbe in the soil. Water is essential for photosynthesis, the process by which plants produce energy from sunlight. It is also necessary for the regulation of body temperature, digestion, and the transport of nutrients and waste in animals. In many ecosystems, water availability determines which species can live there. For example, in rainforests, where water is abundant, the diversity of life is extraordinary, with countless species of plants, animals, and microorganisms thriving in the moist environment. In contrast, in deserts, where water is scarce, only a few highly specialized species can survive. These organisms have evolved remarkable adaptations to conserve water, such as the ability to store moisture in their tissues or to survive long periods without drinking. Humans, too, are part of the hydrosphere. Our lives are intricately tied to water, not just for drinking but for agriculture, industry, and energy production. We use water to grow crops, generate electricity, and manufacture goods. In fact, water is so essential to human life and civilization that access to clean, fresh water is considered a basic human right. Yet, despite its abundance, water is not evenly distributed around the world, and many regions face significant challenges in securing enough water to meet their needs. Water scarcity is a growing issue in many parts of the world, driven by factors such as population growth, pollution, and climate change. In some areas, groundwater is being depleted faster than it can be replenished, leading to water shortages and conflicts over access to this precious resource. Pollution of rivers, lakes, and oceans also poses a serious threat to the health of the hydrosphere. Industrial waste, agricultural runoff, and plastic debris are just a few of the pollutants that are contaminating water sources and harming aquatic ecosystems. Climate change is perhaps the greatest challenge facing the hydrosphere today. As global temperatures rise, the water cycle is being altered in ways that are difficult to predict. Some regions are experiencing more intense droughts, while others are seeing an increase in heavy rainfall and flooding. Melting glaciers and ice caps are contributing to rising sea levels, threatening coastal communities and ecosystems. The warming of the oceans is also having profound effects on marine life, as species struggle to adapt to changing temperatures and oxygen levels. Despite these challenges, there is hope for the future of the hydrosphere. Advances in science and technology are helping us better understand the complex interactions between water, climate, and ecosystems. Efforts to conserve water, reduce pollution, and protect freshwater and marine habitats are making a difference. In many parts of the world, communities are finding innovative ways to manage water resources more sustainably, ensuring that future generations will have access to clean, safe water. The hydrosphere is a dynamic and vital part of the Earth's system. It is constantly in motion, shaping the landscape, influencing the climate, and supporting life in all its forms. From the smallest raindrop to the vast expanses of the oceans, water connects us all, linking the past, present, and future in a cycle that has been ongoing for billions of years. Understanding and protecting the hydrosphere is not just a scientific endeavor, it is a responsibility we all share, as the future of life on Earth depends on it.